This is solving trig equations practice. I know it says homework, it's not homework. This is just our practice time. All right, we're going to solve each equation over the domain from 0 to pi. Let's see, this whole front page is going to be using the unit circle, not needing a calculator. We're going to add 1 to each side, and I get 2 times the cosine of x equals 1. Then I divide each side by 2, and I get that the cosine of x equals a half. So I take the inverse of each side, because I'm solving for x, and these cancel, and I'm left with x equals the inverse cosine of 1/2. Now, because I took the inverse of both sides, I have to look at the entire unit circle, and I want to know where my x coordinates are 1/2. So I just go to my unit circle. X coordinate is a half right here in blue, so it's got to be on another blue. If I come over here, it's -1/2. I want to stay on the right side in order for my x coordinate to be positive, so it's a pi over 3, and if I look down here at this blue, it's also positive 1/2 at 5 pi over 3. The blues on the other side are both negative, as you can see, but at 5 pi over 3 as well as pi over 3. So x equals pi over 3 and 5 pi over 3. Number 2. This is one of those ones where I need to factor. And my first step is to set it equal to 0, and it is already set equal to 0. My next step is to let x equal sine of x. Put this under here. Sorry. I'm just going to say that it's sine of x, and then I'm going to rewrite it as 2x squared minus x minus 1 equals 0, and then I'm going to factor. I know it's going to be two binomials. The only way to get 2x squared is 2x and x. The only way to get 1 is 1 and 1. Because this is negative, one of these must be positive and one must be negative. I'm not sure which one, so I'll start here and I'll see if this works. What I have to do is see if my outer and my inner term will add to negative x. 2x times negative 1 is negative 2x, and positive 1 times x is 1x. Sorry, it's a little messy. Plus 1x, and that adds to negative 1x, which is what I wanted, which means I have factored this correctly. Now I have to put sine of x back in. So I have 2 times the sine of x plus 1, and sine of x minus 1 equals 0. At this point, I need to set each factor equal to 0. So 2 times the sine of x plus 1 equals 0, and sine of x minus 1 equals 0. Now I have to solve each of these. Subtract 1, and I get 2 times the sine of x equals negative 1. Divide by 2. Sine of x equals negative 1/2. And I take the inverse of each side, so x equals the inverse sine of negative 1/2. I know I'm kind of in my space for this problem. I'll just have to do this problem here. So I need to look on my unit circle. Where is my y coordinate? Negative 1/2. My y's I know are negative at the bottom. Here's a negative 1/2 right there. and a y coordinate. So look at my other yellow and look at that, negative 1/2. So it's 7 pi over 6 and 11 pi over 6. So x equals 7 pi over 6 and 11 pi over 6. Now I need to solve this equation here. Add 1 to each side. Sine of x equals 1. Take the inverse of each side. X equals the inverse sine of 1. So I want a y coordinate of 1. Y coordinate of 1. Up here I see a y coordinate of 1. That appears to be the only place. I never see a y coordinate of 1 anywhere other than at pi over 2. So x equals pi over 2. So I have 3 answers for this one. I have 2 answers for this one. All right, let's go to number 3. If you notice, this right here was one of my factors that I did right there. So this is just going to give me practice in doing this again. I'm going to go through my steps again. Subtract 1 from each side, and I get 2 times the sine of x equals negative 1. I divide. So then I divide by 2. And I get that the sine of x equals negative 1/2. So I take the inverse of each side, and I get that x equals the inverse sine of negative 1/2. So I'm looking on my unit circle for where the y coordinate is negative 1/2. Y coordinates are negative at the bottom. And I have a negative 1/2 here, and I have a negative 1/2 here at 7 pi over 6 and 11 pi over 6. So x equals 7 pi over 6 and 11 pi over 6. And that's for number 3. Let's go to number 4. Number 4 has already been factored for you. So you have to, it's kind of nice that you get to skip all the steps of substituting and factoring and putting the sine or cosine or even tangent here back in. The factors are already done for you, so you get to skip to the step of setting the factors equal to 0. So I've got 3 times the tangent squared of x minus 1 equals 0. And I have tangent squared of x minus 3 equals 0. And I'm going to solve each one. So I'm going to add 1. Let's see, I might separate these a little in case I'm going to need that extra space. So I get 3 times the tangent squared of x equals 1. Divide by 3. And I get that tangent squared of x equals 1/3. So then I'm going to take the square root. So I get that the tangent of x equals plus or minus, because I put that square root in there, 1/3. Well, I know that the square root of 1 is 1, and the square root of 3 I don't know. I do need to rationalize this, because you can't have a radical in the denominator. So I get that the tangent of x equals plus or minus the square root of 3 over 3, which I know is on the unit circle. I take the inverse of each side, and so I get x equals the inverse tangent of plus or minus the square root of 3 over 3. So I'm going to look on my unit circle for where the tangent is the square root of 3 over 3, positive or negative. So tangent, I see right here, it's square root of 3 over 3. So it's going to be on all my yellows. See how this is negative square root of 3 over 3. This is positive square root of 3 over 3. Negative square root of 3 over 3. So on all my yellows, all my pi over 6's. So x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. For number 4, I'm going to add 3 to each side. And I get that the tangent square root of x equals 3. I take the square root, and I get tangent of x equals plus or minus. I put that square root in there, therefore I have to remember the plus or minus. And I recognize this as being on the unit circle. I take the inverse of each side, and so I get x equals the inverse tangent of plus or minus the square root of 3. So I go to my unit circle looking for a tangent to be the square root of 3. See, and I see that that happens on blue. Positive square root of 3, negative square root of 3, go down here to these blues, positive square root of 3, negative square root of 3. So it's on all my pi over 3's. So I get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So for number 4, I had 8 total possibilities for x. Let's look at number 5. All right, we haven't had one that looks like this. I'm thinking we should set it equal to 0. Let's see if that will help. So I'm going to subtract cosine of x from both sides. And I get cosine cubed of x minus cosine of x equals 0. This is not a quadratic, so I can't simply, I can't factor it the way I would factor like number 2. But I do notice that these both have a cosine of x. When you did learn how to factor, the very first kind of factoring you learned to do was look for if they have anything in common. And so that it was called the GCF, the greatest common factor. Well, both of these have a cosine of x in them. So if I factor out the cosine of x, it means I'm pretty much dividing it, I'm pulling it out to the front. If I divided this by the cosine of x, and this by the cosine of x, I'd be left with cosine of x squared minus 1. Well, now what I can do is set each of these factors equal to 0. Cosine of x equals 0, and cosine of x squared minus 1 equals 0. Right, let's solve this one first. Take the inverse of each side. So x equals the inverse cosine of 0. So where is my x coordinate? 0. Well, I look and I see that that happens at the top of the unit circle at pi over 2, and at the bottom of the unit circle at 3 pi over 2. So that's what I get for this first one. Sorry. X equals pi over 2 and 3 pi over 2. This next one I'll start, but you might have to finish this one on your own. Or actually I can do it on the next video. Add 1 to each side. Cosine squared of x equals 1. Take the square root. Cosine of x equals plus or minus the square root of 1, which I know what the square root of 1 is. It's just 1. So I'm going to take that off. Take the inverse of each side. X equals the inverse cosine of plus or minus 1. So I want my x coordinates to be positive or -1, which are at 0, 2.